Hello, I'm making this video to help with the Calculator Lab 1.5, and I hope to do 3 questions from that page. And I just want to start with the first question, which is to solve the equation 4x plus 3 equals 12. But it says to solve by graphing and to sketch the graph. Most of us are familiar, I'm sure, with how to do this algebraically. We want to isolate x. And to do that, we're going to use additive inverse, and then we're going to use multiplicative inverse and isolate the x, and there's our answer. And that would be probably the simplest way to go about it. However, this asks us to do it by graphing, and it's sort of a graphing exercise, and to get us familiar with the graphing calculator and one of its capabilities, which is to find a zero. In order to enter it into the graphing calculator, we're going to have to isolate the expression and set it equal to 0. Right now we have 4x plus 3 equals 12, and rather than isolate x, what we're going to do is subtract 12 from both sides and move it over so that this over here is a 0. Remember that when y equals 0, you're on the x-axis, and on our graphing calculator we're going to be entering it into the y equals part of the graphing calculator. Now, just to review, to turn on my graphing calculator, I press this button down here, which is on. And, whoops, I have a different function there. Okay, so if this isn't the screen you see right away, then you press the y equals button and you'll see that. And what we're going to do then is enter this equation, 4x minus 9, into the y1. So that's 4x is up here, minus 9. Okay, so we've entered it into the graphing calculator, and now we're going to touch the graph button over here. And it's going to draw this equation for us. And we know it's a line. We know it's a degree 1 linear equation because the exponent on the x is a 1. So how do we know what the 0 is? When I look at this graph, I can see that it looks like it crosses at -9, and there are limitations to this screen. The pixels are very large, so the accuracy from just looking at it might be tricky to see. But I can see that here at -9, and I also know that from my equation, which is in the form y equals mx plus b, if y equals mx plus b, my plus b is a -9, that's my y-intercept. So I know that I should see the y-intercept at -9, and again, this is the y-axis. But what is on the x-axis? When we're on the x-axis, that would be when y equals 0. If I name this point, right here, that's the point 2, 0, 1, 0, 3, 0, 4, 0. Y is 0 when I'm on the x-axis. Well, it appears to be between two integers, so I'd like to know exactly what is it. And the calculator will tell me if I do this. I'm going to go to second calc, that blue function there, it's the trace button, second calc, and I'm going to get this screen. And this screen has the word 0 here. When I see that, that means it's going to tell me to find the 0. So I just scroll down to that, or I could press the number 2, and then I enter that. Now, the screen has some information I just want to go over. Up here is y1 equals 4x minus 9. The reason for that is because I may have more than one function entered into my calculator, y2, y3, and it's telling me right now my cursor, and you can see in my case there's a flashing cursor down here. Yours could be anywhere on this line, but mine is here. And it also tells me where my flashing cursor actually is. It is at x equals 0, y equals -9. So I know that that is a point on this line. And it wants me to tell it what is the left boundary of the 0. Remember, I chose the 0 function in calc. What is the left boundary of the 0? Now, the 0 I'm actually looking for is right here. So I'm going to scroll over, and when you scroll on your line, you only use the left and right arrows. The up and down actually moves you from one function to another if I had more than one function entered into my calculator, which I don't at this time. So I'm going to scroll closer to where I want the calculator to show me a 0 using my right arrow in this case. And notice you'll see these numbers change, and all that is telling me where on my line my cursor is. So I scroll near that, and then I enter that, so that my calculator knows I would like to look to the right of this. This is the left boundary of where I would like the calculator to look. And now it's asking me, what right bound would you like me to look at? Right now, you're at this point, and I'm below the x-axis because I see the y number is a negative number. So I would like to go to the right of that place where the line crosses the x-axis, and tell the calculator to find a 0 in there. So I'm going to enter that. And now notice up here, I see these 2 arrows. The calculator understands that I am looking for a 0 between these 2 spots. And whenever it says guess, just enter it again. It's going to round off my answer. But it gives me an exact answer here because it is a rational number. So my 0 is at x equals 2.25, y equals 0. Oh, that makes sense because look, y equals 0. Now there is more information I could get from here. It's not so much asked for in this particular lab question, but if I go to second table, which is the graph button, I can also see a table of values. So if I do want to graph this line, I can choose a table of values here. So when x is 0, y is -9. I know that that's on my line. So I'm going to go ahead and graph that. When x is 0, y is -9, -5, 6, 7, 8, 9. So there's a point at -9. Okay, it also tells me when x is -1, I'm sorry, when it's +1, it's -5, and when it's 2, it's -1. So +1, it's -5, and at 2, at 2, it's -1. And then I can take my ruler and I can connect those. And I do highly recommend using a ruler. In fact, I really insist upon it. I need a couple more hands here to do this. And then I have a line. Oh, that just did not draw. Let me try a different pen. I have another pen here. Here's my line connecting those points. Oops. Okay, got a straight edge. Nice. Okay, so on my line, then this is the line y equals 4x minus 9. Now, of course, the solution we're looking for is right here at this 0, which is the point 2.25, 0. And remember that we solved it algebraically, and we got the answer was x equals 9/4. And since x equals 9/4, that's the same thing as 2.25. So when x is 2.25, y equals 0. Now, certainly you might be thinking to yourself, boy, that seems like a lot of work to solve that when all I have to do is do it algebraically, and that I would agree with. However, we are trying to learn the idea of how a graphing calculator could solve this equation. And this is a nice, easy linear equation. It is going to help us with more complicated equations. So let's look at another one that's a little bit more interesting, I suppose. And that is number 4, which gives us the equation, the absolute value of x plus 5 equals 7. Okay, so once again, we're going to use the graphing calculator to solve this, and we're not going to solve this one algebraically because you have 2 equations to solve. We could do that, but right now I want to use the graphing calculator to solve it. So I'm going to make this a 0 by subtracting 7 from both sides. Now I'm not going to try and put the 7 in here because remember I have two equations for this, but I'm going to use the graphing calculator to help me. What I want to enter into the graphing calculator then is this expression, and then put it in for y equals. Okay, and then we'll find where y equals 0, which is anytime we're on the x-axis. So let's see what happens. So now this is where I left off my graphing calculator. So what do I do now? Well, I'm going to go to second quit, which gives me back a blank screen. And then I can go to y equals. Actually, I could have gone right to y equals there. And then I'm going to clear this out by using clear. And now I'm going to enter this new equation in here, or expression in here, which is the absolute value of x plus 5, take away 7, equals 0. Okay, so in y1, how do I get absolute value? Well, I have to go to the math button here, and then I have to scroll to the right for num, or you can scroll left or right, either way. But under numbers, num is the first thing is abs, and that's absolute value. So I enter that, that's what I did, I entered it. And it came into my screen. And now it says abs. Okay, so now inside the parentheses, we're going to put x plus 5. So we have x plus 5, and then we have to end parentheses, because those little lines that are sideways like that are the parentheses in our case. Okay, and then now out of the parentheses is minus 7. Okay, now once again, I'm going to look at a graph, and so I touch the graph button, and we can see that this graph actually goes down like this, and absolute value symbols, absolute value graphs usually have this V shape to them. Now what happens is in my screen, which if you touch the window button, I can see my screen has an X minimum of -10. That means over here is -10, and an X maximum is +10 over here. But we can see if we go to the graph that it looks like it goes past -10. So we'd really like to open this up a little bit. It doesn't look like it goes very far past -10. So what I'm going to do is I'm going to reset my window. So see the window button, enter that, and scroll down to my X. Oh, don't scroll at all. You're at X min. I would like to go further left. And remember, left and right is my X axis. So I'm going to go further left by making this, I don't know, let's make it -15 and see what happens. You don't even have to enter it. You just go back to graph. Okay, so now this point over here is at -15. You can see that it's not symmetrical. This is 10. This is 15, -15, +10, -10. So now I can see where it crosses the x-axis, and that's important because I actually have two solutions to this. And remember, with absolute value, indeed, we have two solutions. So what do we want to do? Remember what we're looking for. We're looking for when y equals 0, right? We've solved this equation to get a 0. And so what x gives us that y is 0? Okay, so let's find this 0 first. So I'm going to go to calc. It's a second function, second calc. And I'm going to choose 0. I just entered that. You can press the number 2 also. Now my cursor, and yours may not be where mine is right now, but my cursor shows this spot here, which is -2.5, -4.5. That's not really where I want to come over here. Okay, so what I'm going to do is I'm going to scroll left. I'm going to press the left button. That's what I'm doing now. Pressing left, and you can see your cursor moving. You can see my cursor moving. Hopefully yours is moving too. And I really want to get to the left of this. I have to come up above the x-axis. So now I'm to the left of the spot where I'd like to find a 0. And now I'm going to enter that. And notice my little arrow shows up to say, oh, okay, we're going to look in here. Yes. Now, do you want, what's the right bound? At this time, these numbers are really insignificant. They just tell me where the cursor is at this moment. I can tell that I'm above the x-axis because this y value is positive. So now I'd like to come to the right of this point right here being my 0. I want to come to the right of it, and so I'm going to end up making sure that my y is negative. How do I know when I've gone far enough? Is when my y is negative. Okay, and I kind of like to just go where I can, really see it, make sure it's in there. Enter. Okay, so now the calculator is saying, would you like me to look between these 2 points? And that is yes, that is where I'd like him to look, him, her. And so guess always just means enter that because it's going to round off the answer if it's not a whole number or a rational number that can be rounded easily. Okay, so look, we have a 0 at -12. Y is 0 when x is -12. So that is a solution. So I'm going to, on my graph here, just plot here, -5, 6, 7, 8, 9, 10, 11, 12. -12 is a point. Okay, but that's not my only 0, is it? Okay, so what do I have to do? I have to find this other 0 because we have two answers. Okay, so let's tell the calculator again to go second calc 0, number 2. I can just press number 2 and it will go right to this operation here.